Celestial navigation, local hour angle. Boy, today's study has got me dusting off the cobwebs of my brain. I don't like math, and with the added complication of degrees, minutes, and seconds. Arrgh. So local hour angle, LHA. What is that? I hear you cry. Well, let's find out together. You will recall from one of my previous video that we can work out the ground position of the sun at any particular time by using the sun almanac. The position we are given in the tables is the GHA, Greenwich hour angle, and declination. The local hour angle, or LHA, is the angle between our assumed boat meridian position and the meridian of the sun. Remember, meridians are the lines of longitude. So in other words, the difference between our longitude and the sun's GHA. We need to know this angle to work out our position. The local hour angle is a measurement of how far the sun is to the west of the boat's assumed position. So we have to relate the sun's position relative to our own DR position. Remember that the sun rises in the east and sets in the west. So any afternoon sights of the sun will be to the west of us, but any morning sights will have the sun in the east. But LHA measures the angle of the sun to the west of us, i.e. just about all the way around the world. See example 2 below. Boat with a western longitude. So, in the picture here, imagine we are hovering above the North Pole looking down on the Earth. Our DR longitude is 120 degrees W. The sun's GHA is 140 degrees, which we got from the almanac based on the UTC time we took our sight, 1. So if the sun's GHA is 140 degrees and we are at 120 degrees W, then the LHA is 20 degrees. 2. GHA, longitude, west, H, A, or 140 degrees, 120 degrees, weight 20 degrees. So if we take all our sights in the afternoon, then the sun is going to be west of us. But what if we take the sight in the morning? Check out example 2 in the picture above. Remember, LHA is the measurement of how far the sun is to the west of us. So in this example, our DR longitude is 120 degrees W, and the sun's GHA is 100 degrees. If we subtract the GHA from the longitude, then we get a negative number, so we simply add 360 degrees. 1. GHA 100 degrees. 360 degrees, bien 460 degrees. 2. 460 degrees. DR, longitude, 120 degrees. W, white LHA, 340 degrees. Boat with an eastern longitude. GHA follows the sun all the way around the world and is counted towards the west. However, when you are in the eastern longitudes, things get just a little bit more confusing. So if you are in the east, you add the GHA and longitude east, instead of subtracting as in the western examples above. If the result is greater than 360 degrees, then you simply subtract 360. Example 3. So if your boat's DR longitude is 80 degrees E and the sun's GHA is 10 degrees, then you add them both together to get the LHA of 90 degrees. Example 4. If your DR longitude is still 80 degrees E and the sun's GHA is 340 degrees, then we add those two together to get 420 degrees and then subtract 360 degrees to get our LHA of 60 degrees. So on our site reduction form, we will need to put the GHA and declination that we obtained from the tables, and then our assumed longitude in box 9A below, and then work out the LHA as per these examples. When we are using the site reduction tables, we need a round figure for our LHA because only round numbers are offered in the tables. So if we are in a western longitude, then we should adjust our assumed position to have the same number of minutes and seconds as the GHA figure, because then when we do the subtraction, then we end up with a round figure for the LHA. If we have an eastern longitude, remember we are adding the GHA and the assumed longitude, so we should use an assumed longitude with a number of minutes that will make the GHA's minutes add up to 60. So if we have a GHA of 20 degrees tense, we will want to adjust our assumed longitude's minutes to be 50s. And then when we add them together, we get 60s or wash 1 extra degree. Confused? Yes, me too, but have another read and hopefully it will sink in. We are basically adjusting the number to get a nice round figure for our LHA with no pesky minutes and seconds to worry about. Okay, I think I get this now. I find it easier to draw it out as in the examples above. Let's do some exercises. In the examples below, we are working out the LHA, including minutes and seconds, but remember that when we are using the site reduction tables, we only need a whole round number. Anyway, it is good practice for my non-mathematical brain.